Solve the compound inequality and graph the solution set on a number line. Except for the empty set, express the solution set in interval notation. Okay, so this is a compound inequality, meaning we have more than one inequality. And at this level of mathematics, compound almost always means two. Can mean more, but almost always two. So in this case, we have x plus 4 is less than 1. Has not been solved for x. Sometimes there's a lot of simplification that needs to be done to get this to solve for x. And, now this is a key word, and. There are also or inequalities, compound inequalities. Negative 4x less than 4. So each of these inequalities is going to have a solution. That solution will be an infinite number of x values. And then we'll combine those two solutions with the keyword and to find our final answer that might also have an infinite number of values. Let's start off with our first inequality, x plus 4 less than 1. To solve this, pretty simple, subtract 4 and subtract 4. X is less than negative 3. Done. Our second inequality is negative 4x less than 4. This was a little trickier because when we divide by negative 4, dividing or multiplying by negative numbers, we have to switch the inequality. So we have x is greater than negative 1. All right, so on a quick sketch number line, negative 3 is on the left. Negative 1 is on the right. X is less than negative 3. That would be all of these numbers. X is greater than negative 1 would be all of these numbers. Now notice I'm signifying the less than and the greater than is soft brackets but not hard brackets because we can't be equal to. So if you have less than or equal to, you would use a bracket with an equals in it. But if you just have less than, you would have a bracket, just a parenthesis, etc. for greater than or equal to. Okay, so this inequality has an infinite number of solutions. This inequality also has an infinite number of solutions. But now for the key word and. In order to be a solution of an and compound inequality, we have to be a solution of both the first inequality and the second inequality. Well, there are no numbers that are less than negative 3 and greater than negative 1. So there's actually no solution to both of these inequalities simultaneously. Therefore, our final answer is the empty set, or no solution. So when you're working with an and compound inequality and you graph each solution, you want to look for anything where they overlap. So very commonly you'll have situations like this, and then your final answer is all that little overlap in the middle. But if there's no overlap, then there's no solution. Now, had this been an or compound inequality, then you're looking for what is shaded or what is covered by one inequality or the other, or both. And then you get a lot more solution, meaning that, well, there are an infinite number, usually in both cases, but it covers more of the number line for the or compounds than the and ones, typically. All right, I hope this helps.